Now, the fifth property is a definition. It's not really a property, but it's very important. The integral from a to b of f of x dx is equal to minus the integral from b to a of f of x dx. Now, really, the right-hand side here is an undefined quantity so far. We never said that you could ever do this where the a is less than the b, right? Because this is working backwards here, right? But we just have a convention that that's the definition. Whenever we write down this number, it's the same as minus what that number is. And the reason for all of these is, again, that we want them to be consistent with the fundamental theorem of calculus, which is the thing that makes all of this work. So if you notice, the left-hand side here is f of b minus f of a, capital F, the antiderivative of little f. On the other hand, the other side is minus, and if we just ignore that we say these are letters, if we were a machine, we didn't know which one was bigger than which, we just plugged them in, we would get here f of a minus f of b over here. And to make these two things equal, what we want is to put that minus sign in. Now it's consistent. So again, these rules are set up so that everything is consistent. And now I want to improve on rule 3 here and point out to you, so let me just go back to rule 3 for a second, that now that we can evaluate integrals regardless of the order, we don't have to have a less than b, b less than c in order to make sense out of this. We actually have the possibility of considering integrals where the a's and the b's are and the c's are in any order you want. And in fact, with this definition 5, 3 works no matter what the numbers are. So this is much more convenient. This is not necessary. Not necessary. It just works using convention 5. Okay, with 5. All right? Again, before I go on, let me emphasize, we really want to respect the sign of this velocity. We really want the net change in the position. And we don't want this absolute value here. Because otherwise, all of our formulas are going to mess up. We won't always be able to check. Sometimes you have letters rather than actual numbers here, and you won't know whether a is bigger than b. So you'll want to know that these formulas work and are consistent in all situations.